Empirically grounded technology forecast and the energy transition is a study of more than 2,900 predictions about how much and how quickly the cost of installing solar power would fall from 2010 to 2020. 2,900 wrong predictions. Every single one of them. The average prediction was a 2.6% fall annually, and the highest predicted fall was 6%. What actually happened was a 15% fall year by year. The prices for residential solar has dropped from $7.53 per watt in 2010 to $2.65 per watt in 2021. Utility scale solar went from $5.66 to $0.89 per watt over the course of the last decade. The authors of this study state that perhaps the most remarkable feature is the dramatic exponential rise in the deployment of solar PV, wind turbines, batteries, and electrolyzers over the last decades as they transition from niche applications to mass markets. That niche application was the high-tech sector of satellites, and providing 1 watt for them had a staggering cost of $1,865 back in 1965. But like almost every other technology, the more it's produced, the easier and cheaper it becomes to make more. This drop in prices stems from different things: increase in scale, higher module efficiency, lower module cost, and other tech advances. And there is still room for cost reductions. For example, perovskite solar cell can be a game changer in the industry. But that's for another video. In case you don't want to miss that video when I upload it, hit that notification bell. So prices have declined a lot, but why are solar panels not that popular yet? The reason is no matter how efficient and cheap a solar panel is, it's still useless if the sun is not shining at it, and we only get so much sunlight in a day. You might be thinking, well, we can use solar during the day and switch back to fossil fuels at night, but that's not a practical solution because traditional power plants have a slow ramp up, and if you want to use them at night, you're gonna have to leave them on at days as well. Some of the other renewable energy sources are also not always available. To tackle this problem, there are 2 solutions: wider power grids. There is always wind blowing and sun shining somewhere. If we can link these different areas to each other, they can feed the other whenever necessary. But that's gonna cost a lot of time and money and technological breakthroughs. The other solution, however, seems closer on the horizon: storage. If we can store the excess energy during the day and use it at night, things can work even with a more local power grid. There are many different forms of storage. The most obvious ones are dams and batteries. Thankfully, batteries have been at a price decline and efficiency increase as well. And there are even new batteries being developed that are not as harmful to the nature as lithium-based batteries. With all the technological advancements and using both wider power grids and storage with a mix of other renewable energies, the problem with solar seems manageable and ever more possible to overcome. If you have watched all the way to here, then you probably enjoyed this video. To see more videos like this, sub.